After a relentless series of storm systems, the sky over North India has suddenly cleared. The continuous barrage of Western disturbances, extratropical storms that bring sudden winter rain to the northwestern parts of the Indian subcontinent, has abruptly paused. Across March 24th and 25th, the surface conditions are completely calm. We are seeing unobstructed, warming sunlight, gentle breezes, and temperatures that are starting to gently climb across the region. This vertical cross-section shows thin, wispy cirrus clouds isolated at the highest altitudes. The lower layers are completely clear and stable. These stable conditions stretch continuously from Jammu and Kashmir down through Rajasthan and Madhya Pradesh, forming a massive block of quiet air. But this continent-wide quiet is actually an atmospheric vacuum. It is a highly temporary gap in a much larger pressure cycle that is still churning out to the west. This beautiful, balmy weather is a false baseline. The atmosphere is currently empty, which means it is perfectly primed for a violent collision when the next system arrives on the evening of March 25th. This map shows the macro-level topographical layout of the Indian subcontinent. Here on the western border, you can see a distinct, concentrated low-pressure system moving eastward. This is the new Western Disturbance arriving tonight. By March 26th and 27th, this fast-moving low-pressure system slams directly into the high-altitude terrain of Jammu and Kashmir, Ladakh, Himachal Pradesh, and Uttarakhand. This forces the moist air rapidly upward, triggering massive condensation. The immediate result of this mountain collision is severe, localized weather. Dense cloud banks pile up against the peaks, dropping immediate rainfall in the valleys and fresh snow at the highest elevations. As the storm front spills over the mountain ranges and drops down into the lower plains of Punjab, Haryana, Delhi, and northern Rajasthan, it loses a massive amount of kinetic energy. Down in these urban centers, the impact looks very different. The skies turn overcast, temperatures drop noticeably, and the violent mountain storms are reduced to scattered light rain and drizzle. The Himalayas act as a massive kinetic energy breaker. They take the full physical force of the incoming storm, ensuring that the heavily populated plains to the south experience a moderated weather shift rather than a destructive impact. The storm front continues to drift eastward, stretching into western Uttar Pradesh, Awadh, and the Purvanchal region as a much wider, diffused system. This chart shows a cross-section of the moving weather front. As it travels further from its moisture source over this flat landmass, its internal water density rapidly thins out, and its internal pressure steadily dissipates. By the time this weakened system reaches eastern Madhya Pradesh and Bundelkhand, the front physically fractures. The impact here is minimal, restricted entirely to patchy cloud cover and highly localized, faint drizzle. Further to the south and west, specific geographic zones like western Madhya Pradesh, Gujarat, and southern Rajasthan are effectively shielded from this system entirely. In these untouched zones, the surface conditions remain completely dominant. The air stays dry, temperatures remain consistently warm, and the only sign of the storm passing hundreds of miles away is a smattering of harmless high-altitude clouds. A single Western disturbance does not blanket the Indian subcontinent equally. Its physical impact on the ground is dictated entirely by a strict geographic hierarchy of continuous energy loss. The fragmentation of this storm over the eastern plains on March 27th might look like the end of the event. But it does not mark a return to the clear, calm skies we saw earlier in the week. This timeline chart of the week shows the current pressure wave exiting to the east. It is immediately replaced by an entirely new Western disturbance, already forming and slated to strike North India on March 28th. These incoming systems are operating with relentless frequency. Because cold air is constantly being dragged down from the mountains before the region has time to absorb the spring heat, the broader seasonal temperatures cannot fully stabilize. Navigating this highly volatile chain of back-to-back weather fronts requires accurate, real-time data. You can follow local meteorological tracking networks and dedicated WhatsApp channels to watch these systems develop. True atmospheric stability in this region is an illusion. We are merely living in the brief, deceptive pauses between continuous Western pressure waves.